Right, hello. Today we are going to do a beginner's tutorial. So this is the beginner's tutorial part 1. And we're basically just going to go through things from the absolute beginning. So the first thing we'll do, so if you are a bit confused, there is a quick start video on the website and the YouTube channel to help you get to this stage. We'll go over some of the same things from that video, but first off we're going to clone a file and we're going to create a new app project like that, and so we get this basic stuff here. We'll give it a better name, tutorial. And I've got cables all over my keyboard. This is not working out. And we'll go down here and we'll forget that part. And we have our stage. Click on the little triangle, but we're going to go to the sprite list and we're going to create a new sprite, which we're going to change to look like a circle. Yellow circle. So that was not quite what I was expecting, because I wasn't paying attention. So yeah, that's fine. This is a thing. Oh, I need to have a little arrow. We're just going to change, and we will do this. Alright. It's my little tank. I made a tank. It's pretty cool. So this is my tank in my world, and we're going to learn about some coding. So we're going to get into the scripts. So the script is where you type your computer code. So unlike in Scratch, where everything is drag and drop and you drag things over and they slot together, hopefully one day you will be able to do that, but at the moment all you have is a very boring black and white text editor, and that's where you type in your code. So the very first line is here that's given for you is these two little slashes and a word script. This is just a comment. So comments look like, my spacebar not work. If you have these two slashes, the forward facing going slashes or backward, I don't know, whichever way they are, the ones at the bottom of your keyboard, they are a single line comment. So everything after those two things is ignored by the computer. So just to know what that is. So the first thing we have to think about is, what is a programming language? Well, a programming language is basically a series of commands. Some of these commands can do things dependent on other things, and other ones are just commands to the computer to do a particular thing. So we're mainly going to go over commands that do a particular thing. I will actually start. So you can do some things. So what we could do, so if I look at my here, you can see that our little tank is sitting up here, and we want to turn it around. So we'll go down to the scripts and we will write turn right 90 degrees. All right, I'm not going to, so sometimes at the end of a command, I will put in this little symbol here, which is the semicolon. A lot of languages that look like this, so C and Java and JavaScript, they kind of usually require you to have semicolons. JavaScript not so much, but it's usually better to do that than not. I always put them in by force of habit, but you don't actually have to put them in. So a command is written, the name of the command is this part here, and then they'll usually have a bracket, a smooth opening parentheses or bracket, and then some values that will have a comma if there's more than one. So if there were two parameters or arguments that you're giving to this thing, they will have a comma to divide things. But the turn right command has only one command, and that is the degrees that you're going to turn right. So now that we have that, we have to actually test it out. So unlike Scratch, where everything is kind of like you do things straight away, there's no, you can even click on the commands and it will do the command for you. In Glitter, you have to compile things before you run it. Thankfully, this is a usually very fast and easy thing to do, so it's not like it's very complicated, but there's a bit more work going on in the background that you have to do in order to get your final game or project. So to compile things and to run them, you go to the build menu and you can go compile and run, or you can type Control F9. I almost always type Control F9. Or you can click on the project, which is over here, the top of the project. This is the project details, and you'll see that there's a compile run button, and you can click that. You can even click the compile button up here. So I'm just going to go back to here, and I'm going to go Control F9, and you get this screen here. And so this is the compiled game, and as you can see, our tank has turned right 90 degrees. So this differs from Scratch, because in Scratch you can't just, well, you can if you click on the commands, but in general you don't just do commands in the middle of nowhere. They are attached to things called events. So we're going to go into that. So the very first event that you have in Scratch is called the green flag event, which is when this flag is clicked through all this sort of code. So Glitter follows that. It has a flag event, and you write out the flag event like this. So you type the word flag. This is important. It has to be the word flag. And then you have this bracket and another bracket. So in Glitter in the current form, there's a lot of brackets in places. So some languages try to have less brackets. Some languages just go overboard with having brackets. This is probably the in-between. Excuse me. But there are different types of brackets. So these are the curly brackets, and there are two of them, and they have matching pairs. So just like with the round brackets, there were matching pairs. There are matching pairs with the curly brackets, and the computer will not be very happy if you have another curly bracket in here, for example, but you never finish that one off somewhere, as we will see. I'm just going to check that I'm recording things, because that would be embarrassing. All right. So now instead of doing turn right just whenever, we're going to do turn right inside the flag event. So that will be whenever I click the flag, anything that is between these two curly brackets will be done. So these curly brackets are defining blocks of code. So the flag has a block of code after it, which is what will happen for this sprite when you click on the flag. Now, in general, when you compile and run, the flag is automatically clicked for you. So if I go like that, we end up going back to the same result we had beforehand. If I click on the little green flag down here, though, if I do it properly, I did not do it the first time. As you can see, it turns around. So we're clicking the flag and around we go. So every time I click on that flag, this bit of code is being done. All right, so we have one command. We can type more than one command though. It's not just one command. So we could go move 10, and we could go turn right 90. I'm just going to put the semicolons in every so often. Who minds? I don't mind. And then move 10. The only problem is you're not going to see anything happen because, which is kind of what I would expect. Yeah, actually that is kind of what you would expect. So you're doing a 180-degree turn because you're doing 290s, and then you're moving backwards and forwards basically. I just feel like maybe I should move. I don't know. I have to think it out. Well, what we can do, the thing is you can't see anything happening because it does all the commands really, really fast all in a row. So we will use the pen down command. Pen down. And then when we do it, we should get, or not, I think it's just too big. I can't see what's beneath the screen, beneath the object. So we'll make this 100. We'll make that 100. And then we'll do it again. Ah, there we go. So you can see what's kind of happening here now that we've moved further. So it is actually following this line. So when you say pen down, it will draw a line wherever it moves according to these commands here. So these are the turtle commands. So they work from where you currently are. So this is turn right from where you currently are facing. This is move 100 steps from where you are facing. Some commands, well, lots of commands have different versions. So I can write TR90 if I want. In fact, and if I copy and paste this, I'll just do that. And then I'm going to go turn left 10. So what will happen here is I will turn right, move forward, turn right, move forward, turn right, move forward, turn right, move forward. So if I turn right 90 degrees, which is a sharp right angled corner, then, or a sharp angled corner, like on the side of a book, then eventually or the side of a square, and if I do that 4 times, I will get back to facing where I was. So if I test this now, you'll see that I have now made a square. And if I click on the flag, then I will make another square. I will make another square. And it's slightly off because I have that extra command. So we're going around and we're making all these little shapes every time I click the flag button. And we'll end up back there. And then now we're going over the top of the previous lines. So we made a pretty shape. And you're like, so the important part here, by the way, is this line at the bottom, which is the turn left. So if I don't have that there, so I can comment the code out if I put 2 little slashes in front of things, or I go control / then it will comment that line out. So commenting out means that the computer just doesn't pay any attention to anything after that on that line. By the way, you can put comments after things. So if I go turning again, this part of the code is not a comment. So this will be interpreted by the computer, but the part afterwards for the rest of the remainder part of that line is a comment. So now I've got rid of that. Now if I run it, you'll see that I always end up back exactly where I was before, and you can't really tell, but I'm going over the top of that line and just doing it over and over and over again. Now you may notice there's a few things here. We're doing a lot of code multiple times ourselves, and we're actually beforehand, when we had this, in order to continue on making a pretty pattern, I basically had to click the flag multiple times to go round and round. So the question is, well, is there any way of getting the computer to do some of these things? Well, first off, we'll look at this bit of code here. So this bit of code here is in fact done 4 times. So we've got the same bit of code and it's done 4 times. So we're going to use another kind of command, which is the repeat. So if I say repeat 4, repeat has a block after it. So I repeat, and I have brackets where the things I'm telling it to repeat, and then I have this curly bracket, and this defines a block of commands that will be attached to this repeat. So this works just like in Scratch in a way. Maybe I should bring up Scratch at some point. Hold on. I shall do that in the background. I have indented things to help with readability. So some programming languages like Python, the indentation is the thing that tells the computer what are blocked together. So I'll give a, but in this language it's the brackets that tell you. So there will be a version that I think that will do with spacing. The reason I started with this is this whole toolkit is written in a programming language called Java, and many programming languages that you might use like C#, JavaScript, Java, C, C++, and related languages will use this kind of pattern of using curly brackets and not using indentation. So this is the thing that's kind of teaching you C-like languages is what I normally call them. But anyway, the point is if this thing is outside of this curly brackets, it's not part of the repeating loop. And in fact, we don't want to repeat this 4 times. We only want to repeat it once. We only want this code in here. We don't want all 4 in there because we're replacing the 4 of these with a block that says repeat the stuff inside this block 4 times. So if we go here, I'm going to come back to the indentation, don't worry. And then if I do that, you'll see I'm back in the same situation that I was before. But one thing you will notice is that you can actually see the sprite moving. And that's to follow what happens with Scratch. So whenever you have these loops, the computer will do this 1 frame at a time. If they're all within the same group and they're not within another loop, they will all be done quickly together, one after another. So we'll come back to that in another video, I think, because obviously you don't always want to do that. So we'll talk about how you might do other things. Now, just to make sure that it's understood that what makes a block. So if that is out of the block, for example, then it's only turning right 4 times. So nothing much will happen. You'll just make a line here. In fact, I'll show it to you. It's just one line, and it just does a little spin around in a circle. It's kind of getting stuck in the corner now. So it has to be within there. It doesn't matter if it's indented like that. So the indentation, how you've moved it, is just for you to have your code be readable. It doesn't mean anything to the computer in this programming language. So that doesn't change anything. Nor does it change anything if that was like there and that was like that, or that was like this. So none of that matters. All that really matters is the curly brackets. So you have to have an open one and you have to have a closed one. Now we can do one more thing. We can just repeat again. So we can have this. So I'm turning 10 degrees. There are 360 degrees in a circle. So if I do this 36 times, I will get back to where I started. But again, I want this to be within the block this time. Alright. So we have an inner loop and we have an outer loop. So the inner loop does this bit of code 4 times and the outer loop does this bit of code 36 times. So this is actually going to get done 36 times 4 times in all. But we'll see what happens when we do that. If we go, we'll see it's drawing away very nicely our pretty little picture that we made before. So I think we'll leave that's just the commands for today. So some of these commands can, well actually we'll come back to the rest because this is just going to be a slow and gentle tutorial series. But there is one more little thing that I want to talk about, and that is what happens when you get things wrong. So I've got Scratch here, almost here. Hold on. Hold on, I'm just loading up browsers. Alright, so here we go. Here's some Scratch for you. So you could write this exact code in Scratch. So if I went here, I would go Events, when flag. I would drag this in, and then I would go down to Control, and then I've got my repeat. I'm going to drag in 2 of those. Alright, and then I'm going to go to my motion, and I'm going to add in, I don't know why I can't, okay, I need 1 of those, I need 1 of those, I need 1 of those, and that one was a 10, that was 10, that was 90, so I was going to turn 90, and I was going to move 100 steps. That one's going to go there, and that's going to go there. So if we just look at the code, we have turn right, move. I think I got them the right way around. So this is how it would translate into Scratch. We are, of course, missing one very important thing. We have to get pen, and then we have to go pen down. So most of these commands are in fact in Glitter. So if you want to find out what the commands are, extra commands, you can just click on that and you'll see that there's all these commands that match up with the Scratch ones, but if you click on it, unfortunately it's a bit cramped, you can find the commands. So if I go copy, go here, and then paste. So if I wanted to go to a particular location on the screen, I could go 20. There's a slight mistake, I think, in this. That's okay. It's all a work in progress. But anyway, if you want to find out additional commands, then this is the place to go to. So you can see that it's all the wait, different types of loops, on flag, on key, different types of stuff. So if you're familiar with Scratch, you can use that, and if you're not familiar with Scratch, it's all an exciting learning experience. But anyway, now we've got the same code in Scratch things. If we click on the flag, what have I done wrong? Oh, right, repeat. Okay, let's change these. 36, that's 4. Alright, we'll just stop it. Stop. Alright, it just stopped. Okay. And alright, so this is where you see, this is Scratch. Scratch does things. I don't know what the term is, but on your project as you're working. So if I move this sprite around, that's where that sprite is. If I run something and that sprite ends up in a different location, that's where it is. And I wanted it to be in the middle, I have to move it back or I have to write code. That is not the case here. It always resets back. It rebuilds the entire project and goes back to there. So if you, hold on, let me get out of here. I can move my sprite to over here. It doesn't matter where it was. So I'll actually make a change to the code. So one more command, go random. Right. Yeah, I'm just going to move around, do all that. And now we're over here in a random position. So now my sprite has landed up over here. But if I get out of there and I go back to my default layout, the sprite's exactly where I left it before. It's not changing anything. So I think that's that. So you can see the kind of correspondence between Scratch and Glitter. But in Scratch, the thing that I was going to talk about Scratch with is that you can't really make a mistake. Like, I can't type pen down incorrectly. I can't forget a bracket because there aren't brackets. The brackets are these blocks here. So the brackets are the substitute for these graphical blocks. But of course, in this one I can. What if I type pen dune, pen dune instead of pen down? Well, when I go to compile it, it will come up with this little message here. It will say unknown function in file sprite 0 at line 4 character. You can't quite read it. Not that useful. Character position 2 details the function pen dune cannot be found within scope. So it's basically saying it has no idea what this thing is. So if you don't know where the error was, you can click on the errors here and it will take you to there. And it will usually get that right. So it will say, this is the problem. I don't know what pen dune is. It's like, you've made a mistake here. So you do have to write the actual, and it has to be perfectly correct. You can't write pen downs or pan down, right? It has to be pen down. And also though, sometimes you might make a mistake where you forget a one of these things. This is going to be your bane of your life. Now if I do that, it might give you a relatively incomprehensible error. It will say general syntax and error here. So we'll get out of that. So failed parse. General syntax error in file sprite 0 at line 12. Failed parse on this. And it's not always that good. It should be saying I'm expecting another a semicolon. So it's just the nature of parsing algorithms. Is sometimes it's the sort of, this. Hold on. If you put that back there, usually when it says failed parse, it just means it's missing one of these brackets. You just have to go through. You will get much better at identifying brackets as you go, and at some point there will be a tool to go through and actually tell you what it thinks is the most likely missed bracket. But it's just a quirk of parsing algorithms that what I would call a syntax error, where one of these strange symbols is not in the right place, is usually a bit harder to give better error messages for and to detect than spelling a name wrong. So if I spell the name wrong, this is a semantic error in a way, because you've written the code in the correct style, but you've said something that doesn't make sense. So it's syntactically correct, it's just semantically not correct. Those errors are usually much easier to identify and to clearly explain. But over time, hopefully some of these things will become better reported. The same thing will happen if you do like something like that. It'll be like, what? Or give you a slightly weird error message, because it's not always easy for the computer to understand why things go wrong when you miss out the funny characters. So anyway, that I hope is a good beginning first video. Then there are lots of different types of loops and lots of different types of control structures. So we will come back and talk about that in future videos. So thanks for watching and have a good afternoon. Goodbye.